also can.
Yeah.
Hey, I thought I got the timetable right. This semester. Okay, hold on. Where is timetable? Okay, I think I have the timetable. You are very less class on Tuesday morning. You only have my class from 4 to 6 only. Tuesday, right? Do you want one shot? This is 6 hours. Hey, you have class on Thursday off, and then you have class also 4 to 4. Wednesday, you have 4-hour classes. Okay, 11 to 12, 11 to 1. Only left Tuesday. Only left Tuesday. And like this lah. This one we put to 26. So many constraints. This one we put to 2nd of January. This one now. Give me a date.
Next semester.
Unless I see you next time, then I can.
No, I won't see you again.
You see me on the morning.
Yeah, project management.
Huh?
Project management.
No, only project management. The very hateful software maintenance. Okay.
杂志
Now,
在哪里？
经过那边，它放在两飞的，我去抽，
哪里？
想看。
and then you Friday Friday 11 to 1 your class is Friday 8 to 10 can Friday this one I don't want to make it on 25th 26 alright 26 is today what day? Today is what day?
Today is
6 6, 7, 8, 9, 10. Today is Thursday Wednesday.
Wednesday.
6, 7, 8, 9, 10, 11, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 25th is Monday 25th is Monday. So
27.
25th I 24th, 23rd, 22nd. 22nd of this one Friday Friday 8 to 10. Okay, and then this one this is Tuesday right? Tuesday what time? Very free on the morning one, isn't it? They only have class 4 to 6 B. So how about 12 to 2? 12 to 2 okay, 12 to 2. And then this one is last week one. Which day you want to? Now it's 6 of. Next week is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 of Friday also. 8 sampai 10. Okay. This one. Very difficult. Then we still got 4 hours, 2 hours practical and 2 hours tutorial. Okay.
So online lah.
Huh?
Online better.
Let me check first whether
No need to.
online one. Okay. You let me check first whether can online. Cannot say this one. I don't say you say because someone that becomes the 2.5 boy or 2.5 girl. You know what I mean? Okay. I think Emma and Sen not understand.
No lah, I think sir won't any this kind of 2-5 guy lah. In our class. We also need to work Friday.
Okay, so
Now we internship also.
I see whether can arrange. I check whether can do online.
So no need check lah. Just do online only. Then anytime you want to attend the class, you also can more flexible ma.
If online also good lah.
Yeah lah. You stay your home, we stay our home ma. Good solution lah.
Okay, I see first. Okay. Okay, so now we need to continue with our study already. Okay, is everyone here? 19. Still got 5 students. Okay. Then this is the week 19 students. Next week, 17 students. Week 5, 15 students. Week 6, 13 students. Week 7, 2 students. Okay, now come, let us continue with what we discussed yesterday, last on Monday, right? Monday, okay, this Wednesday, okay. So web architecture, what we came across is web architecture consists of commonly three categories of structure, okay, which are the module, component connector, and the allocation structure. Module actually is to show that the decomposition of your system into a different unit, okay. It's also normally it's reflect to the function, okay, of the system. For this component connector, actually is a dynamic structure. It shows how each unit of the system communicate, okay, and perform the task. Allocation structure is, when we talk about allocation structure, is allocate, okay, means that we try to allocate, let's say for example, the workforce, okay, allocate how are the system component or system module or system unit is going to be installed into different hardware or software. Okay, so this is the allocation. And when it comes to yesterday, this is the summary of the what we call the structure, okay, and each of the example of structure under each category. You can see that for the module structure, okay, we have a decomposition, users, layer, class, data, model, okay, and it shows the usage of each of the substructure under this module structure. Similar to the CNC means component and connector structure, which has the service and concurrency, and then what are it's useful for what, and then allocation structure, and this is the quality, okay, of applying this type of structure. Okay, let's say for example, deployment. What is the quality? We can check, we can predict, we can evaluate on the performance, security, and the availability of the structure. Understand? Okay. Now, continue to the next chapter. Next topic. This one, architecture views. Okay. okay, architecture view. Okay. So what is a view? View means that it's a representation of architecture elements. Okay. Look at this one, the third point. It's a representation of a coherent set of or related set of architectural elements as written by and read by system stakeholder. So it means that in this case, from this explanation here, we can know that okay, each view that we produce okay, is intended for different purpose or intended for different stakeholder. Just for example, for a user, okay, normally what the user need to know about our system architecture or our system design is what are the functions that performed by this system. Am I right? Okay. They are not going to know in depth on how the system perform their task. You get me? Okay. And then for example, developer, they will need to know that okay, maybe how many module, how many components, okay, how these things communicate, okay, to work together. Mostly focus on this one. And then for those who are dealing with the network hardware, setting up the server, okay, help you to maintain the system one, okay. What they need to know is okay, when this system install, okay, which part of the system is going to install into the server, which part of the system is going to install into the client, okay, what type of network structure or protocol they're going to use, HTTP or TCP/IP or what they call the others protocol, okay, or is there any what we call agent that to connect available, understand, okay, how much is the bandwidth and so on. So therefore, in our software architecture, we may produce different views for different purpose, okay, of representation and intended for different stakeholders. Okay, so therefore, this different view may be presented by different diagram. Understand? Okay, different diagram. Okay, so in this case, this is called view. Okay, this is a view. Okay, so and each architectural model only shows one view or perspective of the system. So it means that each diagram, okay, when we show out, let's say for example, class diagram, we only show one perspective of the system only. We did not show multi-perspective of the system. Understand? Okay, let's say for example, I snapshot your photo. Okay, I show you the photo. Means that I can only show, okay, this is your how to say, the photo of you, okay, front photo of you. But I cannot see this side, I cannot see this side, I cannot see the back, understand? Okay, so this is one view, understand? Okay, so it might show how a system decomposed into module. So different view may have different purpose. Some view is to show that okay, how your system consists of how many modules, how a system consists of how many components, okay, and how a system is going to, how is the plan your system is going to be installed. The plan is not the time planning, okay, it's the plan like a floor plan, understand? Your system is going to install, and how your system is going to perform the process, what are the process in the system. So definitely we cannot just use one diagram to present it, understand? So therefore we have multiple diagram, different diagram may have different view, understand? Different view like that, okay? So in this case, there is a genius, okay, a pioneer is also a genius, okay? It's called Cartons, okay? So he has already suggested many years ago, okay, when we want to present multiple views of the software architecture, okay, then he suggests, okay, to apply this 4+1 view. 4+1 view, okay? What is the 4+1 view? Means that different view, okay, has different diagram to show the system from different perspective, okay? You can see this one, okay, contents, okay? So what are the 4+1 view here? We talk about the 4 view first. The 4, not the +1, the 4 first. First one is the logical, second is the process, Third is the development. Fourth is what we call the physical or deployment. Development also mentioned as implementation. So logical view is the element, is a key abstract of the element. Okay, process is to address how the dynamic side of your system. Understand? The dynamic side means that how are they going to integrate? How is the process work? Okay, how is the message passing? Okay, so this is process. Development is the organization of the software module. Okay, maybe how you organize the software module. Physical is like I said, allocation structure. Understand? So you can look at this. Development is a allocation structure. Physical deployment is also a allocation structure. So for logical is a module structure. Process is a component and connector structure. You get me? Understand? Okay. This is what is the three category of structure we studied, discussed before. So therefore, you can see that since we are going to have our software architecture to present to different users, so this different view, okay, you may have different diagram, and this different diagram belongs to different structure. Understand? Okay, this is the connection. Okay, so continue. I will start with the logic view first. This here did not mention about the plus one. Okay, now the second slide. Plus one actually is your use case diagram. The plus one is your use case diagram. Okay. Look at this diagram here. It's very straightforward and very clear that each of the view is intended for different stakeholder. Let's say logical view is intended for the end user because it's showing the functionality, the function of the system. Okay. Development view is for the programmer because it shows how the modules or components is being organized in the system. Process view, it shows the process, okay, how different function unit integrate. So this one is for the integrator. Actually, integrator is those developer used to connect different module, different component. Okay, sometimes this integrator task is taken over by the programmer himself. Understand? Okay. So physical view system engineer, those network engineer okay, maybe those operation engineer who supporting or maintaining the system understand? Then you should have a floor plan on both the hardware and the software, how the software is being installed. Okay. So these are the different views. As suggested by Cartons, when we present our architecture, okay, we apply this one 4+1 view. But definitely there is others model okay, to show our architecture. But in our syllabus here, we focus on the 4+1 view. Okay. So now we can see that on the top of this 4 view, there is a scenario. This scenario is the +1. This +1 actually is your use case diagram. Okay, from this diagram, it makes sense, right, isn't it? Why scenario is at the top of these 4 views? Anyone can guess? Brandon, not here. Brandon is in action 2 days already. Hey, 2 days 4 hours already. 4 hours means more than 80%. MC. Oh, okay. Then you apply to the office now. Okay. Hopefully this semester people got bar. Okay. Because they bar this semester, then next semester don't know whether still got this subject offer or not. And then next year, most probably syllabus may change one. Okay, because syllabus is going to keep on updating. Okay, so try not to fail. Okay, then I guess that you might think, I feel or not feel, sir, it depends on you, am I right? Okay, so okay, now when I look at this one, my question is, why scenario is at the top of this 4 view? Yes? Yes. Ahan. Ahan not here. Father. Wei Han. Okay. Wei Song not Wei Han.
Wei Han.
Wei Han, right?
Yeah, Lin Wei Han. president list of the class.
Sure 啊
president list
哦 president list 不是啊
4回0
4 flat 啊
where is not student
Okay. So why scenario is at the top of this 4 diagram, this 4 view? No idea. No idea. Then how about Jackson? Jackson? My question is, we have 4 plus 1 view okay? Why this plus 1 is a scenario, which is the use case? Understand? What is at the top of this 4 view?
Is it can refer to use case to design the system?
Use case to
Refer to the requirement.
Okay. Use cases for us is to capture the requirement, right? Isn't it? So this then you record my lecture. I did not make up or how.
It's okay.
After you edit your video, blur my face. Okay. Now, scenario here. Okay. So scenario is the use case, right? Isn't it? Okay. So everything we do is based on the requirement. Am I right? So there is a connection between the use case to this all 4 view. Without this one, how are you going to derive this diagram? Not possible one, am I right? Is it? So therefore, this is on the top of all these things. Okay? Now, continue. Okay, start with the logical view. Okay? Logical view, okay, the object-oriented decomposition. Logical view also known as design view or conceptual view lah. Okay? So actually it's to support the functional requirement. Okay, what are the systems should provide in terms of service to its user? So therefore, the target user for logical view is the end user. Okay, let's say example is a class diagram. Okay, class diagram. Okay, maybe state diagram also can. Have you heard of state diagram? Okay, so state diagram also can. Okay, so this is the what we call the logical view. Okay, so and also definitely you can see that because this is the object-oriented decomposition, then they definitely apply those theory like principle like abstraction, encapsulation, inheritance lah. Okay, you can see very straightforward. The viewer is the end user. The concern on the supporting functional requirement. Okay, representation is the class diagram. Come to the another view, process view. Okay, it shows the dynamic side of your system. Okay, so it's the represent the process decomposition, not system decomposition. The process decomposition. One main process decomposed into sub-process and so on. Okay. So he shows how the system, okay, interacting process is. Maybe let's say concurrent process or non-concurrent process. Okay, how the process integrate passing message to each other, how the process perform the task. Understand? Okay. So therefore, he also look at number 3. Okay. So address issue of concurrency and distribution, of system integrity, of fault tolerance, and how the main extraction from the logical view fit within the process architecture. So he addressed all these issues here, and somehow in the process view, he also address or consider certain non-functional requirement, means the quality lah. Okay. Means the quality lah. Okay, so this is the, let's say for example, performance and the availability. Okay. Now this is the target viewer is the integrators, the concern on the non-functional requirement. Representation is different level of abstraction, process, thread, communication mechanism, and then what are the diagram in UML we can use to represent this process view. Let's say for example your activity diagram. Sequence diagram also can. Understand? Activity activity diagram, sequence diagram. The next view is the development view, okay, which is subsystem decomposition, also known as implementation view. This one shows that, okay, how the software is decomposed for development. The logical view is intended for the user, it shows the support function, the requirement. But this one, it shows how the system is decomposed for development. Decomposed for development. Understand? It's not okay. Even though we can see that it's a functional, we can roughly predict the functional requirement inside this. But this view actually is decomposed for development. Means that how we arrange those items of the system, into grouping into a correct component or package. Understand? Okay. So focus on the actual software module organization. Okay, on the software development environment. Okay. So sometimes this subsystem may be organized on a layer. Okay, each layer may have related similar functionalities. Okay. The viewer is the programmer and the software manager concerned on how the organization of our system unit or in the system module. Okay. So representation is the layer style, and then what kind of diagram we are going to use here? Maybe our component diagram. Okay. Our component diagram and our package diagram also can. Okay. So the last one, physical view. This is the this one correct. Physical view. So mapping the software to hardware. Okay. So it shows that how the system hardware and how the software component are mapped together and distribute. Or maybe we have our hardware infrastructure here. Let's say for example, this is the room. Okay, I want to install my system. Okay, I have 1 server, 2 server, 3 server, 4 server, 5 server. Understand? 6 and 7, 8. Okay. So and then I want to install my system. Okay, then I should have a flow. I have a plan. Okay, to show that maybe module 1 is installed here, module 2 is installed here, maybe 3 modules. Instance of module 1 is installed here. Understand? And then it shows that okay, the printer is connected to which server? Is it the database server is inside this server or isolated server? Okay, what kind of connection is using? This is you need to draw a plan. Understand? So this plan is represent this one, deployment view. Okay, deployment view or what we call the physical view. Okay, so one of the diagram example is the deployment diagram. The deployment diagram. Okay, so this is the purpose of physical view. Okay, or deployment view. Okay, so and then the intended people to read this one is the system engineer. System engineer. Okay, what is system engineer? System engineer is different from software engineer. Software engineer is more concerned on the software. Okay, system engineer is concerned hardware plus also software. System. Okay, hardware plus also software. So this system engineer normally is those who are supporting the system. Okay, and then those who are setting up the infrastructure of your system. Okay, but however, this is definitely this is theory understand? Okay, but however, in certain company they would have such a very clear dedication of responsibility one. Understand? Okay, so but however, this one is in terms of theory. Okay, so we say that the intended audience should be the system engineer. Okay, yeah. So test and there may be 2 architecture under this category. So test and development and the deployment. Okay. Now, you can see that use case the last view, the +1 view. Okay, it's not the last one. This we call as the +1. Okay, there's no sequence. Understand? Okay, +1 view. Okay, actually is on the top of the previous 4 views. So this is, okay, it's a scenario, okay, scenario or called as a use case view. So when we call as use case view or scenario view, okay, so is to shows the use cases. Use cases actually to support or to show a functional requirement. Understand? The functional requirement. From the use case, you will know the functional requirement, right? Isn't it? The use case diagram. So it serves as a driver to discover the architectural element, okay, as a validation and illustration role after this architecture design is completed. So from the scenario, we can help us, okay, to drive us to identify what are the elements required in our architecture. Am I right? Without the requirement, how are you going to know what element is it? Okay, even though you don't know what kind of system you're going to develop. You get me? Okay? So example is the use case diagram. Okay? And then viewer is all user of other views and embedded everybody. Okay, everyone, okay, in the project. And somehow it's also, sometimes they involve the end user also. Okay? Concern, okay, driver to discover architecture element, validation and illustration. So we consider is the system consistency and validity. So the diagram is the use case diagram. Okay? These are the 4+1 view. Any question? Ask. Any question? Yeah, you record. Last Monday, I screamed you don't record. Yeah, you become very popular already. Okay. Yeah. So, okay. Before we come to discuss this slide, any question? 4+1 view. Yes. I want to ask someone else. Yes. Zhang Jue, understand?
No, I don't understand what you said.
Huh? What is that?
I don't understand what you said.
Oh, last Monday.
Last Monday.
Oh, I also don't know. What's happening? I feel that someone is touching me. Okay. Yeah. So, I'm scared. And then the time, the light, I think the lighting is
Ready.
not lighting. The lighting, not lighting. The lighting is quite not that bright. Okay. And then the time, Brandon suddenly stand up saying that he got something else. I say, oh, okay. So, am I? Okay. Yes. Yishan, any question? Any question? No. Then how about Wenjun? No. No. Really? No. Okay. So this side, my right hand side. Sometimes I cannot differentiate. Wait, what is the left side, right side, right hand side? Yeah. Any student? Any question? Wei Han. Wei Song. I'm sorry. Wei Song. Any question? Sam? Emma? No. And then this side, in front, first rank. Yvonne. Our brother, second row and third row. No question. No question, Okay. So no question, then we will proceed this slide. Okay. So actually, you can see that even though there is 4+1 view, actually each of the view is interconnected one. As from our previous lecture, we also know that each of the diagram is interconnected one. Alright, okay. So therefore, you can see that each view are also interconnected one. Let's say for example, from logical view to process view, you can see that, okay. We start with logical view first, and then move to the development or process view, and then finally go to the physical view. You can see for your project, that's why I asked you to do this class diagram. After the use case, class diagram. Am I right? And then after that is your development component. After that is your process. After that is your requirement. Okay? So I follow this 4+1 view. So from logical to process view, okay. So two strategy to analyze level of concurrency. What we concern is the concurrency. I don't know whether you have in your program you got concern on this one or not. Okay. So start with the logical structure, and then outside in is starting from the physical structure. Okay. So from logical view to process view, let's say from each of the classes there is a method, am I right? Okay. So each method is it you need to identify, okay, under certain process which method or which classes is involved. Understand? So therefore you may draw your sequence diagram. Okay, yeah. You may draw a sequence diagram which object is involved, and then each method, okay, within which object is being triggered by what are the message. Understand? So then you need to think back on the logical view, okay, add back the method, okay, maybe readjust anything which is necessary. Okay? Now, from logical to development, you have your class diagram. Then how are you going to show the system decomposition for development? Remember, I very emphasize on the word for development, for this development view. Because when we want to develop the system, okay, actually this view is for the programmer to see one. So programmer, what need programmer to know? You need to group those classes, okay, or items or component into the which perform the same intended for the same group of functions, okay, together, so that the programmer will know, okay, I'm responsible to do this, I'm responsible to do that. Maybe let's say for example, you group into a component, let's say okay, order component, inventory component, okay, maybe what we call bank gateway component, understand? Okay, maybe payment gateway component, understand? Okay, so in this case then the programmer will know, okay, this is what the programmer do. If you look like, okay, you just give them a class diagram, then how the programmer will know what are the how many how many program module they need to develop? No idea one, am I right? Okay, so group to the subsystem based on classes. Remember, we do the package diagram. Okay, we group the class, we group the use case. We can also group the classes. Okay, so this is the purpose. Then we can from there slowly, then we can produce our package diagram or our component diagram also can. Okay, so this is how we do it. Then from the no more already. Okay, example this is okay. Now we can look at this one. Now class, be open your mind, okay. Don't die go and memorize this one. You ask me earlier. I mean, don't statically memorize this thing. Why? Because when you go and find internet, Google, okay, so you are going to see that different author or different people, even though the information industry, maybe you try to search on the what we call the Stack Overflow, is it? Okay, so different people, they may give different answer for this one, understand? Okay, so but why like that one? Because you can see certain diagram, okay, they can consist of multiple purpose one. Okay, now just now I say that logical view, class diagram, then you may ask, how come sequence diagram is under logical view? You see that? Okay, then it depends on this sequence diagram on how you draw it and what is the purpose to draw the sequence diagram. Understand? This one I say sequence diagram is under process view. Activity diagram also can under process view. Okay, this is based on our logical thinking. Understand? Process view, okay, activity diagram, sequence diagram also falling. Understand? So therefore, it depends on the diagram there. Okay, what are the things we have drawn inside and what are the things we're going to show. Understand? But in terms of theoretical, okay, so I will say that logical view, class diagram, okay, so and then process view, activity and sequence, development view, component package diagram, physical view, deployment diagram, use case diagram is that. One is very sure is the use case diagram scenario. Everyone speak the same language. Others, they will have different opinion. Understand? Okay, but however, in your study here, in terms of academic study, okay, so you can follow this one. Understand? Okay, you get me? Okay, yeah. Now, Any question? Any question? Okay, no questions. We take 10 minutes break. Okay, and then not and then continue with other class. Okay, it's not dismissed now. After 10 minutes, we continue with the class. Okay? Yeah. Encyclopedia to pass SDA. Marketing strategy. Wow. Many those here, just in here. Anyone got write your own notes? Any student got produce your own notes for the subject? Got? Like this you can see. So see. Okay. I'm not sure you are producing your own notes using the laptop or just write on yeah. Writing is better. I prefer writing. I don't know, maybe I'm the older generation. Okay, so somehow my eye cannot look at the screen for a very long time. Okay, so I prefer to use this one. Notebook. This is what we. Last time I studied this is what I call notebook, not the notebook. Okay, notebook. Okay, yeah. Very efficient one. This one very efficient one. When the lecturer says something, I just write down, and then because there is like this slide here, okay, then I can just do a summarize that this is how I study okay. Yeah. Last time, sometimes some subject last time I study some subject even don't have this one. It just give us a reference book. Reference book like this thick one. Then you have to. After the lecture, you jot down everything, then after that we need to go back to the reference book, not reference book, and then do our own study and extract those important, we think that is important sentence, point for our. Actually, this is the correct way of study, right? Isn't it? Okay. Yes, while waiting for others to come back, okay, we still have around 9 minutes. Okay, now what can we do during this 10 minutes? It's like sorry, because this is my character. I cannot stop talking. Okay, so yes, maybe have an ice breaking. Okay, take this opportunity. Start with after Sam. Yes, brother. Yeah. Besides Sam, yeah. So yeah, can you introduce yourself?
Introduced already last time.
What's your name?
Darren.
Sorry?
Darren.
Darren. Oh, then your friend eh? Your friend
can call me Hai. H-A-I.
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 Hi, okay.
我看你照片给他。
So, oh, I call you Hi.
Yeah, Hai.
Okay.
Better don't call me like
Okay. Then, come to this side. I slowly try to memorize. Darren and Hi. Okay. Today 2 students sufficient. Okay. This snapshot, this is the proposed tentative replacement class. Okay, the date for the replacement class. Midterm is chapter 1, 2, and 4. Chapter 4 tomorrow lah. Because just cover almost 80%. A little bit not cover only. I guess it's going to rain already. I can hear the rain is coming. You can see the sound of rain. The sound of rain. Then raining, you cannot go back, then you can continue. Raining, you cannot go back, then we continue our lecture. But don't worry, next time you're going to see me again for another subject. Okay, so next time, how come 20? How come only one group? There should be another group, if I'm not mistaken. Or maybe they study other subjects. Still got another 2 or 3 minutes. Anyone here got brother or sister study IT in here before? Any student got brother or sister study IT? Your sister is your brother. No, other. I mean, in this, you got don't have all. So are you going to join my? Have you taken Yishan, Zhang Jue and Wenjun? Have you taken the 3003 already? software maintenance got already all passed already Yeah, okay. Yeah. And how is your assignment progress, class? No progress means. Okay. Happen to this semester, we all look like very tired one.
Because you got final year project.
Oh, finally project. This only project 1 only then project 2 okay. You see, really very tired, but very challenging. After the project 2 I think, actually it's nothing only. You see, it's nothing like that one. After project 2 you'll be very busy, okay. Do until 3 o'clock, 4 o'clock, okay. Then after project 2 you submitted already, then you came back, it's like, nothing one, so easy one, Then when you go out, you think back of your project, this project I can finish within 2 days. Yeah, sure. Okay. Because you already got the experience of industry already. Then you think back on this project, this one 2 weeks can finish the program already. Not 2 weeks, 2 days. Okay. So yes, waiting for one student. Is it time already? We got 1 minute. Okay, I guess we can continue already. Yes. Architectural style or pattern. Yes. Now, class, when we want to draw our software architecture, okay, so there is certain what we call layout or format. Layout, you know layout, okay. Let's say for example in the classroom, okay. Now, excuse me. Okay. When we want to, let's say for example our classroom, how are we going to arrange the chair and the table and the projector and the screen, okay? So then we have a plan, okay, showing now the Q105, the table layout is arranged is in vertical row, okay? However, there are 2 horizontal row, okay? And then there are 2 main vertical section, okay? And then each section got 1, 2, 3, 4, 5, 6, 2, 4, 6 row, okay? So I'll show you how this is arranged. So in this case, you can imagine this what we call this plan, okay, have what we call layout. Am I right? A layout, or in more common word, we call as a format. Okay, we call as a format. Okay, layout or format that to shows the plan of our classroom. So as we know that this architecture is also a blueprint, okay, of a system. So somehow, okay, it also consists of certain layout or format, and then it also inside there not only shows the layout, it also shows the unique elements, okay, that is belongs to the system one, similar to our classroom. Not only we have 2 sections showing 2 sections of sitting, and then each section got 6 rows, but it will also shows how the table arranged. So this table is the element, am I right? Okay, it's a set of elements similar to our architecture. Each of the architecture may have a certain layout or a style or format, and also it shows that how the element of the system is being arranged according to this layout and the format. Understand? So this thing is called the architecture style. architecture style. So why we have this what we so-called the style or the layout or the format? Understand? This is because due to sometimes we need to fulfill the requirement. Okay. Let's say for example in our classroom here. Okay. Then the requirement. Let's say for example only okay. Let's say the what we call the university, okay, need to each of the classroom need to have a middle path for the student to walk, okay, and then in front and the back of the classroom need to have a certain space for the student to enter to the classroom and exit to the classroom, okay, and the classroom should have at least 2 doors, okay, one is for in, one is for out, and maybe one of them is for the emergency exit. You get me? This is the requirement, no? Similar to the system, okay? To the system. When we look at the requirement there, okay, then we try to arrange the format or the layout, okay, and what are the elements we put inside, how the element arranged, okay, in the plan or the architecture. So then, in order to fulfill this requirement, so when after you create the architecture, it will show certain layout, understand, or format. To show that how this system element is being allocated, arranged, okay, under the system structure plan. Okay, as we know that system structure plan actually is the architecture. You get me? Okay, so therefore, from time to time, okay, this so-called format structure is referred to this architecture style. Understand? This architecture style. Then look at this. Look at this, this one. Now I want to enter giving lecture. Must be very careful because it's recording. Suddenly I just fell down. Then next week we will see me again. Okay. Okay. Now, look at this one. You can see that this style, okay, is a specialization of element and relation type together with a set of constraints on how they can be used. It is a conceptual way, conceptual, high level of how the system will be created, will work. Okay? So it means that a specialization of element means that those elements which is inside the system, okay, the element of the system, okay, and how these elements are related together, okay, and within a set of constraints. I said constraint means that not necessarily is maybe it's let's say hardware constraint, okay, software constraint, technology constraint, other constraint, okay. So and how they can be used, okay. So now it contains a set of rules, constraint, and pattern on how a structure to structure a system into a set of element and computer. Same thing with just now the example of our classroom here, a set of rules. Now let's say for example, student go into the classroom must follow this door. Okay, and then when you want to move inside to this row, okay, first student sit at the most inside one, second student sit at the okay, and accordingly understand, and then the next student, okay, again like this, understand, okay. So this is some of the rules, okay, and then another example is the rules is let's say for example, okay, when this student want to go out to the room, okay, he need to okay, how to say, excuse, okay, maybe the student need to go out and then the student so that he can go to the toilet, whatever, okay. So some of the rules, set of rules, okay, and constraint, everything we do is within the constraint of this classroom, okay, within the constraint of this classroom. Pattern, the layout, this is the layout, okay, and the system into a set of elements, this table, this one, okay, it's all the element. Okay, similar thing to our software architecture. Okay, there is a style, a layout of architecture, and then how this element, system element is arranged, how they connect, understand, what are the rules that should follow, and so on. Because different style, okay, may have different rules that need to follow. Okay, so govern the interaction of flow control. Just now I say, look, you control the flow, okay, and how the data is being transferred. Okay, now continue. Okay. Common style have emerged that describe element of the system together with their relationship and quality characteristic. Definitely. Now the relationship, let's say, of this table here, okay, each is connected to each other. Student can talk to student beside that, but then difficult, they cannot talk to the student. The first row student cannot talk to the last row student when they're sitting. Understand? Okay? So they describe the connection. Understand? Okay? So, and the interrelationship. Okay? So now, architectural style. Describe a class of architecture or the significant architectural pieces is found repeatedly in practice. Why is repeatedly in practice? Because when we in system development or system software engineering, normally we are going to develop the same category of system. Let's say for example, we are going to develop a web system. Okay, let's say online purchasing, online ordering system. Okay, one is online ordering system for the clothes, okay, shirts. One is online ordering system for the food. One is online ordering system for the what we call the groceries, okay. One is online ordering system for any other thing. But however, in terms of software design or software engineering, actually regardless of what kind of item you are selling, okay, actually most of the online system is more or less the same one. Am I right? More or less the same one. Then therefore he said repeatedly in practice. Okay, it means even though different system I sell online food, online grocery, online what, actually the stuff is more or less the same. Understand? So is a coherent package of design decision. Okay, so it means that this architecture actually is the decision of the development and has known properties that permit reuse. Why repeatedly practice permit reuse? Let's say I have designed a web system online for food purchasing. Then next time I purchase for t-shirt, online t-shirt purchasing. The architecture is definitely is more or less the same, just the data is different only. Am I right? Okay, then I can reuse it. Reuse is not necessarily must be 100% can fit one. Definitely you can make certain adjustment, but the layout, the style is still overall is still the same one. Understand? Okay? In other words, architecture style are like design pattern. Design pattern we are going to talk about on the next chapter. Architectural style is similar to design pattern, but however, for the at this moment, you just need to know that architectural style, the scope is wider. The scope is wider. Understand? Okay. Design pattern, the scope is a bit narrow. Okay. Because architecture normally is for the entire system, for the subsystem. Am I right? Okay. Design pattern is more to a certain part of the system only. Okay. So this is the thing. But however, when we come to the next slide, pure architectural style are rarely used in practice. Definitely, why? We cannot just use a pure one to the first architecture style we have developed, okay, and reuse in all the things. We definitely need to modify, as I said just now, okay. So therefore, when we modify it, then become an architectural pattern. Understand? Okay, to suit on certain system as a solution for architecture of the system. Okay. So, but however, okay, not to be so concerned into the terms here, architectural style and architectural pattern. Understand? Okay, not to be too concerned, because some of the author that just mentioned about style, some of the author that just mentioned about architectural pattern. Actually, it's the same thing. Just that style is maybe is a very native first pattern, and then when you modify it become architecture pattern, okay, then maybe you switch on certain system development, okay, then it become pattern already. Okay, so for my advice, not to be so concerned on those words, architectural pattern, architectural style. Understand? Okay? So actually, when you go internet, you Google, okay, then they always say architectural style. If you put architecture pattern, I think that the Google will return you almost the same thing. Understand? Okay? So, but since this is academic, so we just let you know, okay, maybe want to differentiate it. Style actually is what we call like the high level or the first version of the classes that we develop, okay, the architecture. When we want to use into other system, okay, similar other system development, we may need to amend it, whatever thing, or this become a pattern already. Okay? So but however, not to be too concerned on these differences. Understand? Okay? So therefore, okay, you can see that because when we modify this architecture style become a pattern, then this is because we need to switch this style into a specific system. So this pattern will become a solution for a certain development problem. Understand? When we say that, okay, when you study your problem solving and programming, right? Okay, each of the question or each of the program they ask you to do actually is referring as a problem. Am I right? Okay, so therefore this architecture pattern actually is referred as a solution for a problem. It's a solution for a system, a specific system. Understand? Okay? So style is more general, okay? So this is what is the difference now. But again, not to be too concerned, okay, on style and pattern. This style is pattern, this style is pattern. Actually, sometimes it's very difficult to really differentiate one. Understand? Okay? Now, architecture must understand the pure style to understand the strength and weakness of the style, as well as the consequences of deviating from the style. Okay? So means that you need to understand the overall common characteristic features, okay, or constraint of a certain style first. Then we come to some regarding the characteristic, the weakness, the strength of a certain style. Okay. Then as many of the original architecture style have been reformulated as an architectural pattern. Okay. So this is the what it means the architecture pattern. Okay. Now, you can see that it's almost the same thing. Okay. Architectural pattern is determined by a set of elements. Okay. Or system unit, system component, whatever. Okay, classes okay. So a topology layout, okay, is a layout there. Okay. Style also got layout okay. But this is amended, maybe it's an amended one. Okay. And this layout showing the connection, okay, between the system element, okay, and a set of semantic constraints, okay, a set of interaction mechanism that shows how they coordinate, okay, through the or within the topology. Architectural patterns are similar to software design pattern, but have a broader scope. This is architecture more to a system level, or maybe subsystem level, okay. So design pattern is more to a certain part of your system. Okay, maybe a part of the coding. Understand? Maybe a part of the module, or maybe for a module. Okay, so this is the difference. Architectural. Any questions before we proceed? Before I proceed. Any question? Any question? Class, that side. Any question? No. No. There are different meaning of no. No means you totally understand. Another no is totally don't understand what I'm talking about. Any question? Subject, any question? No. Ambiguous answer. So, now, how about Jason? Okay. You have any questions, please ask me. Okay, I will try my very best to make you understand. Okay. How about the side? Any question? Any question? Very quiet this class. Okay. Definitely totally different with your last semester, your senior one. Okay. Are you joining my class on the software maintenance last semester? No, no. Okay. Last semester, your senior very proactive. Okay. Very proactive. Yes. Okay. And then continue. Classification of architectural pattern. So these are the classification of architectural pattern. Okay, 1, 2, 3, 4, 5, 6, 5. Oh, so many. Okay, 1, 2, 3, 4, 5. Yeah. For this slide, okay, it shows the 5 classifications of architectural pattern. We have hierarchical, we have data center, we have data flow, we have distributed, we have interactive. Okay. So, but I guess for today we cannot finish all. Okay. Definitely need to proceed next week. Yeah. Definitely cannot finish. Okay. So, it's true because this chapter got 121 slides. Okay. So if I finish 121 slides by today, I don't know what is the consequences or what is the outcome. Okay. Now, hierarchical, data center, data flow, distributed, interactive. Hierarchical actually is where the system is, the architecture, the system is arranged, okay, in a hierarchical way. Maybe it's from, let's say, one layer after another. Okay, maybe most simple is in maybe it's a structure chart. You understand? Okay, so it reflects to a different level of abstraction and responsibility. It's in a hierarchical way. So data center, okay, maybe you can say that okay, one level is more, how to say, more abstract, another level is less abstract, and so on. Data center is served as that is a centralized repository. Okay, I mean there is a centralized database. I use the word database. Okay, instead of data repository, because database is more easy to understand. Okay, data repository is like some sort like a very common terms. Understand? Okay, so you can it's either way lah. Okay, so they have shared, and then all the client is connected to this data repository. Okay, we are going to in detail discuss this one. Okay, after this slide. Data flow, it shows that okay, how the data is being transformed and being transport. Transport means being how data flow, okay, and being transformed, processed to transform, and passed to another process. Distributed is involved the interaction between component or processing unit, okay, with, on a network. Network can be a local network, can be an internet. Understand? Distributed, okay. Interactive system that serve is more on focus on the user centric. Okay, so interactive. Now we go more detail on each of the category of architecture pattern. Now, class, this is the category of architecture pattern. Hierarchical, data center, data flow until the interactive. This is not the architecture pattern. Understand? Each category consists of different example of architectural pattern. This is just the name for the category of architecture pattern. Okay? Come to the first one. First category or first classification. Hierarchical system. Okay? So as within this hierarchical system category, okay, the architecture pattern normally is to categorize, okay, arrange, okay, the components or the system element, okay, in a hierarchical fashion. Hierarchical we know okay, one level until another level, okay. So which is different level of abstraction, and each level, okay, address a particular concern, okay, of a software system. For each level, okay, of the system in in this hierarchical system, okay. So you can see the system element, okay. Maybe the component, okay. And then you go to, okay, maybe he branching downward to another component that is carry out others operation. So two common patterns, two common architectural patterns fall under this category. Maybe one is then is the main program and subroutine, another one is the layer architecture. Now, the main program and subroutine is the architectural pattern. Layer is also the architectural pattern. Hierarchical system, this one is the category name, understand? Okay? So main program and subroutine, actually this one you can brainstorm or imagine on a structure chart. Okay? Now look at this one. Main program and subroutine. Used is the structure of functional design strategy. Okay? A main component consists of those main global data for the program and allowed to share among the sub-module. Okay? So quality, okay, modifiability because we decompose the system into different independent components. Reusability, each independent component can be reused with other system. Okay, when we talk about component, normally component, remember, component is referred to an independent working unit. Understand? Okay, why we do have component? Because we try to maintain low coupling. Okay. For example, this one, main program and subroutine. Okay, you can see that this main program, okay, so we have other subroutine here. Okay, maybe the main program have the shared memory that this subroutine can access to the same memory to share the data. Okay, and then even the subroutine 1.1 can integrate or communicate with the subroutine 1.2 and so on. Okay, so this is the main program and subroutine architectural pattern. Okay, another one is the layer architecture. This layer architecture is a very common architectural pattern that found in designing the web system. Okay, last time or until now still don't understand. Okay, when we design a web system, okay, normally, especially for those web e-commerce system, okay, so normally we are going to use the layer architecture. Layer means that normally we present the layer is in a vertical way, 1 layer, 2 layer, 3 layer, 4 layer, 5 layer. Okay, but however, some diagram they also represent the layer in a horizontal way, 1 layer, 2 layer, 3 layer, 4 layer, 5 layer. Also can one understand? Okay, so please be reminded. Now, layer architecture. Okay, how is it? Why you have 1 layer, 2 layer, 3 layer, 4 layer? Because each layer they have grouped all those elements, okay, system element or system component, okay, or even modules, okay, that is have performing the same functionality one. Same functionality means that, okay, maybe, okay, this element, okay, is for presentation or user interface purpose. Okay, then we group into 1 layer. Another layer is for the business logic, perform the business logic. Maybe let's say ordering logic, inventory logic, and so on. So these all perform the same business logic one, okay? So we put another layer. Maybe another layer is for the we do the data persistent logic one, processing one. Okay, let's say data persistent for order or data persisting for inventory. Then we put under 1 layer. And then the last one is maybe it's a database lah. Okay, so we group into different layers. Understand? Okay, so each layer represents a different level of abstraction. Okay, and for example, operating system communication protocol. Okay, they are applying this layer architecture. Definitely, other some of the web system they are applying the layer architecture also. Now, communication protocol. Have you learned the OSI model? Okay. Do you study network? Introduction to networking. layer. Okay. So that one is actually, this layer actually is a logical set grouping, understand? We cannot see, it's a logical grouping, okay? But when the user see the program, they cannot see the layer one, understand? Okay? Now, flow, what it means this topic flow on the layer, how the flow of control or how of the flow of data, okay, between the layer is, okay, this one I think when I say like this one, you will understand one, okay, this one hold on for a while for the flow, and then we come to use when building this layer architecture is used when building a new facilities on the top of the existing system. Then you put another layer, okay, at the top of the existing system. The development is spread across several teams. Different layer, okay, you will assign to different teams. Maybe first layer you assign to this team. Second layer you assign to another team. You assign to another team. Okay. So there is a requirement for high-level security. Then you can apply the layer architecture. Okay. So layer architecture got two types. Okay. One is open, one is closed. Okay. What is the difference between open and closed? Come to this one easier. Okay. Remember the flow just now I said we go on for one the flow okay. Open open layer architecture. The open architecture, let's say the flow this is the highest one this is the lowest one am I right? So the open one, the highest, okay, they can use the service on the third one. Skip this one. And then this one, he can skip the immediate bottom layer to access to the service on this layer. This is the open layer. For common closed layer, cannot. Common closed layer, let's say assume this one is the common closed layer. This one can only access this one. This one can only communicate with this one and this one. Understand? This one can only communicate with this one and this one. Okay? And this one only can communicate with this one. Understand? If this one want to pass the data to this one, okay, then he need to go to this one, and this one, and this one. Understand? Similar and vice versa. This is for the closed. Open is different. Understand? Okay? So this is the flow of this layer architecture. Open and closed. Any questions?
Sure.
Any questions?
So is it the open one must skip or cannot skip also can?
Cannot skip also can. It's not just open one. You no need to skip also can one. Maybe it depends on where is the service in which layer Understand? Okay. Is the service is in the layer n-1 then they go to the n-1. Understand? They not necessarily have a follow that okay. N must go to n-1 and n-1 must go to n-2. No. For open layer, you can n go to n-2. It's an option understand? It's an option. Okay? Yeah. You can see this is the closed architecture, not closed layer architecture. Okay? How many layers very good. This is a good question. When you design a system, if you are using layer architecture, now you can see this is the layer architecture. Okay, so this is the layer architecture. This is not the one whole diagram. This is 1, 2, 3, 4 different example of layer architecture. Okay, so now one is 2 layer only. Application and database server. So your application is in the client, only database in the server. Okay. This is 3 layer. This is very common C1. Okay, common layout. Presentation, business logic, and database. Presentation layer is for the user interface log. This is the business logic, and this is the database. 4th layer, presentation layer, application, domain entities means that this is beside the application logic. This is the domain logic. Okay. So and then this is the database. Partition layer 1, 2, 3, 4. Just now I said we know what we learned is this presentation layer is for those all the user interface one. Sometimes we need to further group or separate okay into different partition. Maybe let's say okay, this is UI1 is for the ordering, UI2 is for the inventory, UI3 is for the maybe payment, UI4 is for others. Understand? We can partition also in the different layer. Understand? Okay. So if you want to further partition this is the different layers, showing the example of 2 layers, 3 layers, 4 layers, and partition 4 layers example. Okay. Now I have a question. When you develop a system, how many layers is sufficient? Let's say I want to develop an online, very simple online. Let's say Shopee Okay, like Shopee one online. Shopee is what online. I cannot say food online purchasing system Okay. So how many layers if I want to use layers? Who can answer this question? It is your homework. Anyone want to volunteer to do some finding? Anyone want to do volunteer to do a finding on this one? How many layers we should use?
Depends on your budget and your scope.
Maybe it's in terms of technical we forget about the budget and the scope we forget about the budget Okay. So anyone want to become the volunteer to find out? Can I appoint? No volunteers We had again. You must owe your friend a lot of money. Okay. So Weihan is branded, right?
So just call Brandon or we had same people, so just call we had.
Weihan is excellent, right?
No, Brandon, Weihan is different person.
Different person. Weisung or Weihan?
Weisun is
魏汉
Weisun is Weihan.
Weisung,
Yeah.
Weihan.
Yeah. Weihan's room and Weihan's seat.
Oh, okay. Then not brother or?
Yeah, brother.
Not brother. Okay, then okay lah. Then I will appoint any volunteer.
郑介
How about person at the last student at the last row? No. Anyone want to help me to find out this answer for this question? How many layers is sufficient in creating an online purchasing system? 3 layers. What?
This layer is cumbersome.
Is it possible to have 7 layers or 6 layers? Another question is how many layers is sufficient? Maximum how many layers? Because if you have too many layers, it becomes very difficult to maintain a system already. Understand? Okay. So how many layers is the maximum? Do you think of this one? Any volunteer? I want someone to help me to go and do some homework, and then next week come back and let us know. Maybe I will assign. Those are very quiet one. Okay, never say anything. Okay, so yes, behind Weisung. Behind Weisung, yes, yes, brother. Happy family day. Yeah, okay. So, yes, brother, what's your name?
Jason
Jason.
Jackson.
Jackson. You're Jackson. Then you're Jason also.
Jason.
Jason.
Jackson
Okay. Jason, okay. Jason, this is your homework. Okay. 2 questions. How many layers for this shopping website? Okay. And how many layers is the maximum? Okay, suggested maximum layer Okay, there is no office rule actually, understand? Okay, but what is the suggested maximum number of layers? Two questions, huh? Okay, Jason. Okay, so next week, Monday morning. Okay, so we are eagerly looking forward. Okay, on next Monday for your answer. Okay, a very formal sentence. Okay, now. You can see that 3 layer commonly used for business-oriented information system. I guess presentation layer, business logic layer, data access layer. Okay, presentation layer is the UI, okay, to display the data or to format the data. Business layer is the business rule, validation, and task that is going to perform business tasks. Okay, data access layer, okay, include the database communication. Okay, so like executing a queries, okay, how to persist the data and so on, okay. Benefit of applying layer architecture: more code can be shared instead of duplication. Yes, within the same layer, okay, sometimes the code will be the same one. Understand? Let's say add edit, CID, okay, almost the same one, you can share instead of duplication. Developer can change the content of any one of the layers without making changes to the, for example, you change the UI, okay, it will affect the business layer. Understand? Okay, you change from one DB to another will only require to change to the data access. If you change the database, then you have only changed to the affect the database access layer only. Understand? Exactly, but this is very ideal lah. Okay, understand? But sometimes it also depends on how you design a system. Even though you apply a layer architecture, if your design in the way of a very high coupling, okay, very tight connection, then sometimes it will affect others layer in a certain degree. Understand? Okay. So possible to use different team of development to work on each due to having separate layer. Let's say for example, Java developer for business layer, SQL developer for data access layer. This one raised another question. I don't know why today I got so many questions. Okay. So I show the diagram. This one, okay. What just now the slide say, well, I think we cannot finish. This one we can assign to the SQL database team. Okay. This one we assign to the Java programmer team. Let's say we are using Java, okay. Now, my question is, what is the limitation that we assign the team, okay, in handling this, that I treat this one as a one system, a whole system, okay? What is the limitation or drawback? We assign the workload, the team, okay, in doing the development in this way, according to the layer. Homework. Volunteer. Any volunteer? This time I want to ask this side. Yeah. Okay. So any volunteer? Good afternoon. Yes, I am Mr. Lim here. Okay, nice to meet you. Okay, so then
You also Mr. Lim?
Devon, right? And hi. Okay. So good afternoon. Yes. Any volunteer? Maybe I can ask the help from Hema. Hema, can you do it? Can you help us to find out the answer? Okay, you know question, no? Okay, means that let's say I assign the workload, okay. Let's say I assume that this is for the entire system. Okay, then no SQL team, no SQL database team do this one, programmer team do this one for all the module. for all the module, okay, for all the module and component, understand? And then programmer do this one for all the module and component, and then business logic and so on, understand? What is the drawback in assigning the team in this way? Okay, you understand, Emma? Okay, so same thing, we eagerly looking forward for your answer on next Monday. Okay, so others please help me to remember the question I asked and who is the one who answered the question. Okay, because maybe after tomorrow I forgot already. Understand? Okay? Yeah. Okay, now this is benefit. Just now we have talked about this. Then 4-layer architecture. Okay, so 4-layer architecture means that they further separate the business logic into application logic and domain layers. So this is the business logic. Okay, the second one. If you have 4-layer, this 3-layer only. The database not count. Okay, so this 3-layer, when you have 4-layer, the middle one, the business logic layer, they further separate out into application and domain. Understand? Okay, application logic and domain layers. Sometimes because it's felt that it's too complex already, understand? They have to separate out into different layers. Okay? Advantage. Just like it's also advantage. Okay, this one advantage of the 3-layer. This one advantage of the layer architecture. Actually, it's almost the same point. Abstraction. Okay. So layer architecture abstract the view of the system by providing different layers but sufficient detail, okay, to understand the role and responsibility of the system, okay, in individual layers. Encapsulation, no assumption need to be made about data type. Because this is provide an abstraction, then you do need to think about, okay, the data type, method and property, implementation during design. Because this is the architectural style, it's a conceptual layer. Understand? Okay, we haven't go into the detail that shows that the property, the data, all these things. Understand? So we just provide sufficient information, okay, for us to understand the system plan. You get me? Understand? Okay. So I always use the word sufficient. But what I mean by sufficient means that not overloaded information and not too least information. Sufficient. Okay, there is no rules. What is mean by sufficient? Okay, so it depends on how you design system. Okay. Yeah. Clearly defined functional layers. Okay, so each layer is clearly defined. Okay, this layer is for what kind of function? For user interface representation, for business logic, for data persistence, for domain logic, and so on. Reusable, lower layer have no dependency on higher layer, potentially allow them to be reusable to other scenario. He said potentially only, okay, not 100% can be reused one. Okay, so lower layers have no dependency on higher layers, potentially allow them to be reusable. By right, theoretically, by right, ideally should be able to be reused, okay, in other systems. But however, I say if your system is too complex, if you have too many layers, and then it's a very high connection, then it's difficult to reuse sometimes. Understand? Okay, so you need to be careful. But overall, ideally, okay, when you apply layer, okay, it also allows reusable. Okay. High cohesion, yes, because all similar function is grouped into one layer to achieve the task. Okay. Loose coupling, because the ideal concept is each layer you do is will affect other layer. Okay. Okay. Any question, class? Any questions? How come today I'm very slow one? Until 59. We start at 35, right? No. We start at 30. Okay, any questions? Any question, class? No questions, I think I will stop here lah. Okay. So any questions? No questions? I guess I will stop here. Okay, and then I will see you tomorrow. Okay, for your tutorial. Okay, please get ready for your tutorial answer. So that we can faster complete the tutorial. Okay. Yeah. Okay. Anything else you want to ask us? Yes. Any questions? No questions. Okay. Then you may dismiss now. Okay. See you again tomorrow. Yeah.